Have you ever heard of a theory that called the holographic universe? A theory that says the universe that we know today, this massive three-dimensional reality we live in, might actually just be a projection from a two-dimensional surface. Yeah, it's basically like a hologram. And that's exactly why it's called the holographic universe. And the craziest part is, this isn't some random bedtime story or some fantasy from a movie. This is actually a real concept in modern physics that was proposed by scientists like Stephen Hawking and Leonard Susskind, a physicist from Stanford University.
That in a certain sense, in a certain peculiar sense, the world is a hologram. It all began with thinking about black holes.
And in this video, we're going to talk about that idea, a concept that might completely change the way you see reality itself. So get your brain ready, because some of the ideas we'll talk about might genuinely blow your mind. Let's talk about it.
Do you know what I'm talking about?
The Matrix.
Do you want to know what it is?
I'm pretty sure most of you have seen The Matrix. In the movie, there was a scene where Morpheus offered Neo two pills, the red pill or the blue pill. If Neo chooses the blue pill, he will go back to his normal life. But if he chooses the red pill, he will discover the truth about human reality itself. And in the end, Neo chooses the red pill. And that's the moment everything changes. Because after he takes it, Neo realizes that the world he's been living in was actually just an illusion. All of humanity, including himself, was really lying unconscious inside giant pods, while their brains were connected to a massive machine system. So all this time, everything they saw, everything they felt, was just a simulated world created by AI.
AI. You mean artificial intelligence?
A singular consciousness that spawned an entire race of machines.
Of course, the story in The Matrix is just fiction, but interestingly, there's a theory in physics that feels strangely similar to that idea. That theory is called the holographic universe. According to this theory, the universe that we see today, the one that feels so real, the one with space, time, and three-dimensional form, might actually just be a projection like a hologram.
It says that our ideas of volume, of the real world in a sense, might be a kind of illusion.
This absurd idea first appeared when physicists were trying to understand one of the most mysterious objects in the universe, the black hole. Because the deeper scientists tried to understand black holes, the more they realized that black holes are objects that almost break the laws of physics themselves.
Black holes are those objects, in some sense, the most exotic objects in the universe. They're dense, they're heavy, they're dangerous, but they're also ubiquitous.
Nature has conspired to let us see something that we thought was invisible. We now have visual evidence for a black hole.
A black hole itself is an object in the universe with insanely strong gravity. So strong that it pulls in everything around it. Even light itself gets sucked in. And that's exactly why the center of a black hole looks completely dark. But the biggest problem with black holes isn't the fact that they swallow stars, planets, or even light itself. The biggest problem with a black hole is, where does everything that falls into a black hole actually go? Does it get destroyed? Does it disappear? Or what exactly happens to it? For physicists, that question turned out to be way more terrifying than it sounds. Why? Because in 1976, Stephen Hawking, a scientist many people compared to Albert Einstein, proposed something shocking in his research. In his paper, Stephen Hawking basically said that black holes can actually evaporate. And according to Hawking's calculations, when a black hole eventually evaporates, everything that ever fell into it would disappear too. Not just the physical objects, but even the information inside them would be completely erased. And that's where the real problem begins.
Every object, in some sense, contains information because it contains a very specific arrangement of particles. So where is the information that describes the arrangement of those particles? Where does it go?
You need to understand that in physics, every object in the universe carries information. Information here can be understood as all the details that make up an object. Things like the positions of its atoms, its energy, the movement of its particles, even its fundamental structure are all information that belongs to an object. And this information is what makes the universe the way we know it today. It's what makes one object different from another. Now, according to quantum physics, that information is supposed to be permanent. Even if an object gets destroyed, its information would still continue to exist. It can't truly disappear from the universe. And in quantum physics, this idea is known as the conservation of information. Now the problem is, through his paper, Stephen Hawking was basically showing that the conservation of information in quantum physics might actually be wrong. That information may not truly be permanent at all. Because inside a black hole, that information could disappear when the black hole itself evaporates. And if that's true, then one of the most accurate theories in human history, quantum theory, would have to be completely rewritten. And what made this even more complicated is that Hawking's calculations weren't just random speculation. His results actually came from combining the two biggest theories in physics, the theory of relativity from Albert Einstein and quantum physics itself.
The two great pillars of physics are quantum theory and general relativity.
Yes, Einstein.
So on one side, Hawking's calculations made perfect mathematical sense. But on the other side, the conservation of information was also considered correct, because that idea is one of the main foundations of quantum physics. And this is what completely confused physicists, because now they were stuck in a very strange situation. Quantum physics works, Einstein's relativity also works, and Hawking's calculations were mathematically correct too. But when all of them meet inside a black hole, the final results start contradicting each other. And this conflict eventually became known as the black hole information paradox.
The problem was that Stephen Hawking's initial calculation of the way those black holes evaporate away said that information is not conserved, said that black holes are erasers of information. This became known as the black hole information paradox.
One of the scientists who tried to solve the black hole information paradox was Leonard Susskind. Together with his colleague, Gerard 't Hooft, a physicist from the Netherlands, he proposed a theory known as the holographic principle. The idea of the holographic principle basically started from here. Do you know what this is? Yeah, this is the gravestone of Stephen Hawking, who passed away in 2018. And if you look closely, there's an equation written on the stone. This is one of Stephen Hawking's famous equations, the entropy formulation for black holes. In simple terms, entropy here is related to how much information a black hole contains before it evaporates. But if you realize, there is something strange about the equation. In the equation, Hawking clearly showed that the amount of entropy, or the amount of information inside a black hole, depends on the surface area of the black hole itself. And that is extremely strange. Because from a physics perspective, this equation almost seems to say that all the information from everything inside a black hole is actually stored only on its surface. In other words, the surface of a black hole acts almost like a giant hard drive that can store information. And this is where Susskind started proposing the holographic principle. What if a black hole actually works like a hologram? Why is it compared to a hologram? Because holograms themselves work in a very unique way. A hologram is basically just a two-dimensional surface that records the light interference patterns from an object. And when light hits it again, it can reconstruct those patterns back into a three-dimensional form. And according to Susskind, a black hole might work in a very similar way. Every object that falls into a black hole may look like it completely disappears, but in reality, the information from those objects might still exist, still stored on the surface of the black hole itself. And that idea is what's known as the holographic principle.
What was going on the horizon of a black hole was similar to a hologram, that the surface of the black hole, the horizon of the black hole, was like the photographic film, and what fell into the black hole was like the image created, the three-dimensional image created.
But the even crazier part is, this idea can be extended much further into something called the holographic universe theory. Susskind argued that maybe this principle doesn't apply only to black holes. Because if the laws of physics can work like that inside a black hole, what if that's actually a fundamental property of space-time itself? What if the universe also works under the same principle? What if the three-dimensional universe we see today, the reality that we have always considered real, is actually just a projection of information that's stored on a two-dimensional surface? And that's exactly what makes the holographic universe feel so strange. Because if this theory is true, then the space, time, and even everything in the universe might not actually be the true form of reality. Sounds pretty similar to the story of the Matrix that we talked about earlier, right?
We began to understand the idea was more general, that the entire three-dimensionality of space is a projection of a very distant horizon that surrounds us. And not the horizon of a black hole, it's the horizon of the universe.
Of course, the holographic principle is still just a theory, and scientists still don't really know how to directly prove it. But what makes this idea so fascinating is that it didn't come from some novel. It came from physicists that trying to understand black holes and the fundamental laws of the universe itself. And you guys need to remember, the holographic universe is just one of many theories trying to explain how reality actually works. We don't really know whether any of these ideas are actually true or not. But one thing is clear. The deeper humans try to understand the universe, the thinner the line becomes between imagination and reality.